Models. What are models? So models appear as very important in artificial intelligence. The key idea is that when we want to solve a problem, it is often very difficult to go and ask an expert or to go and check in the field what the real answer is. So we want to be able to interrogate something different, perhaps something more mathematical or something more inside a computer. And this is what a model is. A model is an alternative to reality that we can go and ask questions to. A simple analogy for models is maps. So when we consider maps, the first question is, where do they come from? And historically, there has been a huge history of building maps. First, because there were explorers that were going all over the world to bring back maps and build better and better maps. And then, little by little, the maps were being built through images by balloons and then images through satellites. The same sort of history applies in the case of artificial intelligence. The first models were hand-built, sort of human experts were building these models. And nowadays, most models are built by machine learning. Machine learning algorithms are going to interrogate data and transform the data into the maps, which in this case are called models. The second thing we want to know about maps and models is that there can be various different maps. There are maps to drive a car with, there are maps to go on your bicycle, there's maps which are large scales and maps which are less large scale. And since there's different purposes, well, these maps have been tuned for the purpose and the necessity of each case. Same works with models. If I want to have a model of what a student is, I may have a model which is based on the fact that I'm trying to predict the grades the students will have, or perhaps I'm trying to predict something completely much more ambitious, in which case I will have a different model. And in each case, I might want to use an algorithm that can be different. The third thing is understanding that having a map isn't just the answer to everything. We also have to know how to read a map. And we all know of friends and colleagues and family who are not very good at reading maps, and others are better at it. So you have to find ways, algorithms to read a map. The same applies with a model. Once you've got your model, you're going to have to ask questions to it. And that is going to be a skill which programming experts are going to be good at, being able to use the model to ask more complex questions. An important point is that in a map, there can be mistakes. And sometimes we have been on a road and found that a crossroads that we were expecting wasn't there. So this is due to many factors. Perhaps the measurements have been done wrong, perhaps there's been changes on the road, and perhaps you have some bias, meaning that the map has been intended for one usage and you need it for something else. The example I give is a map of a tube in a city which may not give you which way to go if you need actually a special type of services. This is exactly the same with maps, which are models that are built by computers and that we will use in all the tasks in which modeling is necessary. So even a very good model, because it has been built from data, can have mistakes. So the map can be used to answer questions. If I've got a map, I can find out how to get from A to B, how long it may take for me to get from A to B, how busy am I going to find the roads at a given time. And also I might have some help in knowing which is the best, the most scenic route to go from one place to another. So the same applies for models. Once I've got a model, I can use it in many, many ways to ask many, many questions. So one of the things you can use maps for is to create simulators. And nowadays we have all got navigation systems in our cars which are just that, maps that are simulating the traffic and that allow us to actually know how long it is going to take us to get from one place to another. The same works for a sailor. If you're sailing a boat, you can also use the map to take into account the wind conditions and find the best route. You can use models in the same way to actually build simulators, and the typical example is to do a weather forecast. You're just running your model to predict what the weather is going to be in the next few hours, and therefore know if you need an umbrella or not.